Okay, we're going to continue doing what we were doing for the other videos, which is to plot this first as though it just says y equals 1 half x minus 3. We're going to first plot that. What does that look like? Well, we go down to negative 3, we put a point. And then we rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Right there. Rise 1, run 2. Rise 1, run 2, all the way down there. You can see that my tool is making me be imperfect in terms of where I'm writing, but that's fine. Now, I'm going to connect these with my line tool just for a moment and then talk about whether it makes sense to leave the full line or not. So I'm going to grab it and just adjust it. That looks good. Okay, so does this linear inequality say that the line should be included? Well, you can really break this linear inequality into two things that should both be true. One of them is what you see, y equals 1 half x minus 3, and the other is the inequality y is less than 1 half x minus 3. They're combined together to be the full statement that you're given, y is less than or equal to 1 half x minus 3, but it's really two parts. So any point that's on the line will satisfy this. They won't satisfy this because you'll get the same thing on both sides, but it will satisfy this. And this is one of the two things that are in here. Y can either be equal to, and that's what that is, or y can be less than, and that's what that is. Okay? So if points on the line satisfy that, then we're good. All right. So we know that the line is there, and we know that the line should be included. It shouldn't be a dotted line because it does say or equals, and points on the line will give us the same number on both sides when we plug it in, which means that we will get the equals part of this kind of double combination of this and this. This part will be true that it's equal on both sides. So we're good. Now we need to determine, do we shade above it or do we shade below it? Well, let's look here. Is y greater or less? It says y is all the values less than the line or equal to the line. So we want the y values less than or equal to the line. And that's all the values below it. So we can say, okay, from the line, I shade down, and everything that's below it will be included. Hi, Louie. Kitty Louie is smashing against me right now. Hi, Kitty. You want to say hi to the microphone? Yep. We'll see. She's still smashing. We'll see. So any point in there, in that shaded area, hi, Lou, should work. So, Kitty, I'm recording. So notice that 0, 0 is not part of the solution. And so we can test 0, 0, and it should actually work out to be a false statement if it doesn't fall in the shaded region. Hi, Kitty. I gotta wait. You gotta wait till later, okay? I'm recording. Yeah, okay. Sorry about that. Well, it's the life of Louie. Okay, so 0, 0 right here is not in the shaded area. So if I plug it into the inequality, it should not work. So I'm going to get rid of all my marks up here just a second. And sorry, thanks for your patience. Okay, so now I'll take y is less than or equal to 1 half x minus 3 and put in 0 for x, 0 for y. And see what we get as a result. 0 for x, 0 for y. Okay, so we get 0 is less than or equal to 0 minus 3 or negative 3. Is it true that 0 is less than or equal to negative 3? No, it's not true, actually. This is not a true statement. So is that okay? Yeah, it's definitely okay. We checked a number that was not in the shaded region, and it didn't make it true. So that is a good sign. We should have any values that we check that are not in the shaded region should be false, and any point that's in the shaded region should be true. So 0, 0, when we plugged it in, became a false statement as it should. So that means that we were right to not shade this side of it. Okay, then we're done.